Let's figure out the average stopping force of some planks of wood. Here we consider a bullet traveling with a certain velocity, 335 meters per second, penetrating 8 1-inch pine boards, each with a thickness of 0.75 inches. Using the work energy principle, I think we can do this. We'll say that each of these will be exerting some average stopping force opposing the direction of motion here. And the distance that it's being exerted over is this delta x here. At the end, if it can just barely penetrate those, we're going to say that my velocity of the bullet at the end here is going to be 0. Let's go ahead and use the work energy principle and see where we get. Work energy. I know some people are like allergic to writing things like words when they're solving problems. I recommend writing words. It helps keep track of where did this even come from. Work is equal to KB minus KA. So this is state B, state A. Finally, if our velocity is 0, we'll end up with some 0 kinetic energy. This gives us work equals the negative of whatever kinetic energy we started with initially. Let's further bring in the definition of work. Where we said that our work, here this is going to be the average, work is the average force dotted with our displacement. That's our average stopping force of our bullet times our displacement times the cosine of the angle between them, which is 180 degrees because it's opposing the direction of motion, which gives us a -1. Continuing, we have negative FAV, average force, times delta x as our work. We can combine this with the first statement and say that negative F average times my displacement is equal to negative KA. Multiply by a negative on both sides to cancel those out, and replace my kinetic energy here with 1/2 mVA squared. Okay, we're almost there. We want the average stopping force. We have an equation that's almost there. We just have to divide by delta x on both sides. And as long as we know everything here, we can plug in numbers and get an answer. Let's do that. My average stopping force now is equal to mVA squared over 2 delta x. Our numbers we have from the problem statement of 2.6 grams, or 2.6 times 10 to the minus third kilograms. I feel like I should have given myself just a little bit more room. VA is our initial speed of 335 meters per second. And then twice the stopping distance. If we have 0.75 inches, we got to do a little bit more work. No. All right, 8 boards, so 8 times 0.75 inches gives us 6 inches, which we can then convert into meters, 0.1524 meters. Use the 2.54 centimeters per inch, 100 centimeters per meter. That gets us to meters. So now we can plug in 0.1524 meters. And rather than try and squeeze it in the very corner there, I'm just going to plug it over here and say, once we calculate that, we have 960 newtons worth of stopping force on average for each of those boards.